I just went and googled a few things, and I saw half of the post being like a beginner emulator to try it out on chip 8. It seems
I did not check anything. I was folding
you were
clothes.
watching parkour videos.
I was folding clothes.
uh, have you tried emulating chip 8? Maybe.
No, I didn't. But yeah, it is hard because it has a GUI part to implement.
Yeah. I
So
did see that.
it's just more than just a VM. Uh, yeah.
Hmm. Probably if emulating is interesting, I should maybe start with that. Okay. Your graphics processor is going good.
Okay, so I haven't read this document yet, so I'll go through it while.
Yeah, take your time, take your time. Like in the meantime, let me just. I don't need to take notes, correct?
Yeah,
You sure, right?
yeah, I'm sure.
Okay, let me just eat my dinner.
It says that each instruction has a fixed 2 byte length, and that is much helpful. And the instruction represented as hexadecimal, where x can be any value between 0 and f, are listed below, divided by their role. So we kind of have the whole instruction set here. And what? Oh, okay.
Oh, yeah, and then one more thing. Like if you go to the top, like in the intro section of this document,
Hmm.
you would actually see something mentioning like 8-bit and 12-bit, like a little bit down, like overall description.
This one.
Yeah, you see, yeah, like it says an 8-bit register A and a 12-bit register PC. I mean, how do we actually comprehend that part?
Oh, so yeah, look, so as you can see, this x is 4 bits, right? Then this is
4 bits.
8 bits. 8 bits is 1 byte. So one x is a
How do
nibble.
you say that X is 4 bits?
A byte is a byte is 8 bytes, right? 8 bits. I mean,
Of course.
8 bits. Yeah.
Yeah,
So
yeah.
so each hex nibble, this hex digit is called nibble. Each hex nibble is 4 bits.
Okay.
Each hex nibble is actually 4 bits.
Yeah, yeah.
Oh,
So I'll tell
okay,
you.
that's
I'll tell
that's
you why. I'll tell you why.
sure.
Hey
Uh,
bro, what you doing? F. Hello.
yeah.
I guess he's explaining the nibble bits and
What?
bytes.
Oh, someone joined me in this Discord.
Hello.
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 Yeah, so
Hello. We
yeah.
are on
Yeah,
we are on the Google Meet.
okay. Let me
What are you
join.
doing?
Come, take a look.
Okay, we are gonna have a lot of spams. Let me
Uh,
just read.
Yeah.
so, so as you can see, the
Okay.
yeah,
Other mute,
highest
please.
value that you can represent in one hex digit is f. Okay, and if you convert that
Uh,
into binary, it is 4 bits of all ones. And if you
oh,
yeah, if you add one to it, it'll go in the fifth bit. So that's why I'm saying
oh,
each hex digit represents it can be represented by 4 bits. So that's why I'm saying that each this x is 1 bit is 4 bits. Then you combine two x's and that becomes 8 bits, and then you combine the
yeah.
third x, that becomes 12 bits. And
So the
Oh,
digit one that you're adding, that is actually a single bit,
uh,
correct?
can you repeat?
The digit that you're adding with 0xf plus
Yeah,
1, that is actually a single digit.
yeah, that is
Single.
yeah.
Yeah.
Okay, so that's not considered as an integer in this, correct?
No, it is considered as integer.
No, if it is considered an integer is a 4-byte value. So,
No.
no, it will be there at
You're
zero
getting
zero
me wrong.
zero one.
I'm
Zero zero
what
zero one.
I'm trying what I was trying to say. So you know that one. So this is also one, and this is also one,
Beta.
right?
yes.
Okay. So here, what I'm saying is when you add one bit like you add 1 to this number, the least amount of bits that are required to represent this number is 5. That's what I'm saying, and that's what I'm saying here, that the least amount of the least number of bits required to represent a hex digit is this, because
Okay.
the
What is
maximum
0xf plus 1 in hex?
what
0xf plus 1. What is
that is
that in
that is
hex?
hex 10.
Okay. Okay. All right. All right.
So similarly, if you think about decimal numbers, the minimum, the largest number that uh, can be represented by one digit in base 10 is 9, right? And then when
Yeah. Yeah.
yeah, so let's so for example, if you want to represent a 4 in decimal, and and someone asks you that you can't talk about the you can't talk about number of bits in decimal, but yeah, that doesn't make sense.
I mean,
Just
you can say it in binary, right? Like
yeah, in
a
binary,
decimal value
yeah,
can
in
be.
binary, let's see this. In binary, for example, you have hex ff, right? So it is,
Yeah.
yeah, so if you convert this to binary, you will what will you see? You will see 8 ones. You get 8 ones.
Okay.
So this is 1 byte, right? Hex ff is
Uh-huh.
1
Yeah.
byte,
Yeah.
and if you add 1 to it, it will become ox what no yeah, it'll
Yeah. It
become
will be a one
ox 100,
digit.
which is over 1 byte.
Okay.
So in let's say 4 in let's say 4 in binary is what 0 1 0 0. Why I'm appending a 0? Because I'm talking because I'm considering 4 bits here, so that's why I'm appending a 0. So 0 1 0 0.
Okay. All right. All
And
right.
I'm consider this, okay, wait a minute, this is a hex digit.
Yeah, because rest of the zero is just an
Yeah,
appended value
yeah,
padding, just padding.
yeah, but now let's say 5. So 5 is a 0 1 0 1. What will be 5 4? It will be 0 1 0 1, the 5, plus the 0 1 0 0, the 4. So that's why,
Oh,
yeah,
okay.
so that's why this is 4 bits, this is 4 bits, right? Here is a 0,
Yeah,
just,
yeah,
yeah,
yeah.
it's just not there, but it's there. So this is 4 bits and this is 4 bits, that becomes 1 byte. And as you can see, this
So
is,
it literally concatenates the 4-bit value of the single hex
yeah,
level.
that is a property of hexadecimal. That is why we use hexadecimal instead of decimal, because we don't have to convert like the whole number, because if you have 54 in decimal, you have to convert the whole number in binary, and that is
Yeah.
more tedious. But if you have 54 in hex, you can directly convert this to binary by using just just binary of 4 and then binary of 5.
When you're 5.
Yeah, so
Why don't they teach this in school? God.
so the here that is this x is 4 bits, and the total 3x becomes 12 bits, right? And why one more thing, it says that the program counter, which is a 12-bit register. Why is program counter 12-bit register? Because all of the this address space, this only requires 3 nibbles. As you can see, the maximum
Yeah.
address that we go is EF0, and EF0 can be represented by just 3 nibbles, that is 3 hex digits, that is 12 bits. So that's why our program counter is 12 bits.
Okay. That's awesome.
And it says that the accumulator, the only register that this architecture has, is only 1 byte, that is 8
Yeah,
bit
like
register.
EA.
Yeah, like EX. So this is easy to implement. Here I'm just going to first start like something. First of all, I'm going to load the file. So let's say uh,
Wait, is Arjun here? Arjun, are you present? Arjun? Hare Arjun? Arjun, are you present? Ah, shit. Where did let me. Zero, you're free right now, right? You don't have any
No,
commitments.
no.
All right.
So
Okay, that's
this
how
is a
you read
helper
it.
function to load the file. Let's make a class. Do we want to do it object oriented way, or I think we can. Let's just
Object
define.
oriented will be better to
Yeah. Okay.
manipulate and
Class. What is the name of
I am
the?
not sure if Arjun is familiar with object oriented programming.
Uh, okay. I guess let's not do that way. Okay. Is that fine?
Yeah, yeah,
Okay.
yeah,
Let's.
yeah, sure.
So um, we'll define a couple of global variables then. So this is, let's say
Yeah,
this is our emulator code. Here we will this let's say this variable will be our uh, byte array of VM's code. Like this is the code that we are going to execute. Uh,
okay.
and let's say
Arjun, you are present, right? Arjun,
is he?
yeah, he is
No.
present in Gmail.
Oh yeah, he is not responding.
Arjun, he went to maybe do something back.
Okay.
Yeah, you can go ahead. I'll try explaining later.
Okay. mu we are going to define the the accumulator register. I'll call it accu, and let's initialize it with 0, and let's say mu pc we'll initialize it to x 100 because that's said, that's defined in uh, the manual that
PC starts with the 100.
PC should start from the x 100. So let's say and uh, and
Yeah, Arjun
now
is here. Arjun is here. His mic is broke.
now we're going to load the file mu code equals to load file, and the file is sys.argv1. If we can do that here, or no, wait, let's do it. Uh, shit. And then our we'll load the file in the argument. So the file has been loaded. Now we'll just start executing. So we'll have a mu halt maybe. So this is a flag that represents if our CPU is running or not. Is our
Uh,
CPU running?
like a debugger then?
No. This flag represent if this flag is like let's set it. Yeah, if this flag is 0, that means our CPU is running. And when we want to stop our CPU, we'll just uh, set this flag to 1, and our CPU will stop. It will be more clear.
Wait.
Hmm.
Yeah, sure, sure.
It'll be
No, continue.
it'll be more clear when we build it.
Start to use.
Yeah, I'm going to set this to 0 here. Wait. And we're going to initialize it over here. Mu accumulator is already set to 0, and emulator program counter needs to be set to OX 100. And one thing I forgot, global mu. Do we have to do it like every time?
I think so. Can we use it in a single line? I'm not sure. You should first try it. Arjun is saying that we can actually use. Can we actually use it? Use emo halt as breakpoint, like int3. I think.
What? Can we?
Arjun is actually asking, like, can we use that EMU halt as a
Actually we can, but this flag specifically represents that our CPU is halted. That means like stop, like not going anywhere from here, like stop to dead. But we can do
not
something.
pause.
Yeah, we can do something like breakpoint by having a list of breakpoints or something. Yeah, we can do that, but not here, not with this flag at least. So this is our mu init, and let's do a def mu. Now our CPU is initialized. Now we need to start executing it. Okay, so we have to now first of all build. We have to make a function for each of the instructions that we have, and the instructions that we have. Let's start from basic one, which is add. So mu execute. Let's name it mu execute, and we'll have this.
Is there any registers like emu halt and x86?
No. In x86, we have an. Wait. So first, let me tell you one more thing before, so that will clear your mind for this topic. So the need of this flag, I'm going to explain you. In x86, if I'm correct, let me open a random elf file. I can't find an elf file.
That's ironical.
Is that an elf? I don't know. That is an elf. Is it? No, that's not it.
It should be. It's in Rev.
I
So
can't
shouldn't it
find
be
an elf. Okay, this one definitely an elf. Yeah. So I'm going to let's see. I'm confused. Wait, I have to check if that's the case. So we are in the main function. I don't want to be in the main function.
Oh, your idea is colorful.
Yeah, I was talking about this halt instruction. So halt instruction base. I'm not sure if it halts in x86, but let's see what this actually does. HLT instruction x86. Halt is a assembly instruction which halts the central. Oh, okay. So it stops until the next external interrupt is fired. But we don't have a concept of external interrupt or something. We just want to our CPU has only two states: either it's running or it's not running. Okay, so what if you why did I open a paint? Oh, never mind. So what if you're done with your program, right? Your program has executed. For example, you wrote a for loop, and the for loop is supposed to run only 5 times. What if
Mm-hmm.
the loop ran 5 times? What will happen after that?
It will
For
get
example, take this.
completed.
Let's take this file. We started from OX100, right?
Uh-huh.
Yeah. Then let's say we are executing, and we come down here, right? What will happen after we reach the end? We're going to
Uh,
crash because we're trying to execute these null bytes, right?
mm-hmm.
So we don't want to crash. Our program must end somewhere, right? It should end somewhere. So this
Okay,
will,
you're just putting a flag. It's just a basic flag. It doesn't do anything else rather than just
yeah.
giving
So
the
yeah.
making
So
the program.
we will have one instruction called halt instruction, and that will just set this flag to uh, 1. Now I remember why I opened Paint. I opened Paint because a CPU has three basic principles. What is this? Three basic principles, and that is, first one is oh shit. First one is fetch, which means fetch the byte from memory which you want to execute. Then second is uh, decode. That means you figure out what that byte actually means. Is this an add instruction, or what instruction it actually is? And third one is execute, right? So this happens in a while.
Okay.
This happens in a while loop. So while not halted, we continue to do this. Uh, what is happening? What is happening?
No, probably you cannot do talents. Yeah, we get it. We get it.
Ah, so whatever. We just can I can't space press, bro. What the fuck? What is happening? No, Paint sucks.
You are recording. Don't forget that. You know.
So yeah. So that
Wait,
flag.
are you recording your audio input as well?
Yeah, everything is getting recorded. Oh, let me
Okay, then
check.
I should be.
Oh shit. Let me check. Oh yeah, it's recording. Editor, please cut that out, please. Okay. Yeah. so so now we'll just implement the first instruction. So how will you implement it? Um, one way is to first first thing is to fetch the byte from memory, right?
Uh
Hello.
huh.
Yeah. So first we'll fetch
Yeah,
the
yeah,
byte.
yeah.
So the way we are going to fetch it is, as you can see. So we start from OX100. So first byte is C0. Okay, let's say opcode. First of all, while mu halt. While not.
Is not equal to 0.
Okay, while not mu halted. Now we're going to fetch. We're going to decode. And so let's say opcode. We're going to fetch our opcode. What is our opcode? Our opcode is stored in our mu opcode and at the PC. So basically, mu
Yeah, at the PC.
mu PC, and we're going to increment our program counter not like this, but mu PC plus equals 1. So now we are going to point at here, OX00, and then we are going to fetch. Okay, let's not do it like this because it's going to be tedious. Let's fetch, because we know that the instruction is of a constant length, that is, all the instructions are 2 bytes.
2 bits, yes.
Where is it written? I don't know, I forgot. Yeah, here, 2 byte instruction. So we'll fetch all of the 2 byte in a single fetch. So the way we're going to do that is, let's call this instruction equals to, let's fetch the 2 bytes using.
By the way, Kodaker is also joining in, like he said. He's joining.
Joining where?
Here, in your session. He said he's coming. I have a doubt. Like, since you said that this is easier, so does that mean that x86 has opcodes of variable lengths?
Oh yes, it has. It has uh, like I don't remember exactly, but let's say a call instruction is 5 bytes, and a normal, let's say push RBP or something like that is like 1 or 2 bytes, depending on 32
Mm-hmm.
or 64 bits,
Right.
and yeah, couple
Kodaker
others.
is zero.
Yeah, x86 is actually very complex. The encodings.
Yeah, that's why it is called complex instruction set.
Is
CISC.
it? Oh, x86. Okay. I am not actually sure about RISC or CISC. Uh,
Yeah, x86 is CISC and MIPS is RISC, ARM is RISC, and your architecture is also RISC.
Mine? Which one?
01.
Huh?
Yeah, that's RISC because it has a fixed length
No,
for bytecode and all.
which one? Which one?
Your 0VM.
The zero VM.
Yes, it's
I have an
also RISC. You can
XVM.
say
I don't
that.
have zero VM.
Yeah,
Oh,
XVM.
okay, okay. XVM. XVM has variable lengths of opcode.
Oh, then it's CISC. You can say that.
So instruction.
You have your own opcode system and stuff in place.
What? Can you repeat?
You have your own opcode and all those systems in place.
Ye- for my
Yeah,
own VM,
lol.
yes. And it is
For
actually not that hard to implement. You'll understand that. Uh, Only if you try to make one someday. So we'll
yeah,
fetch
you have to make one to learn one.
yeah, we'll fetch the whole 2 bytes and we'll decode it that way. And mu
Wait,
code.
I have one more doubt. You said your x86 is variable length, right?
Mhm.
How do
Yeah.
you then, know at which point to break and start the next opcode? Like, how do you know
Oh,
where and which opcodes are starting? Because you don't have any particular length.
that depends
That
on the
depends
first
on,
byte.
yeah, that depends on the opcode, because for each opcode it is defined that how what will be the length for that particular opcode. For example, call instruction, we know that it will be 5 bytes. For push or pop instruction, we know that it's going to be 1 or 2 bytes.
What about IML? IML can have 1 byte or 2 byte or 3 bytes, right?
uh, IML
What?
IML takes registers as argument, right?
Yeah, yeah,
So
yeah, it does.
so I'm not sure about IML. I haven't seen like the disassembly of IML, but we can check that out.
What is ML?
The, it's the multiplication instruction.
Yeah,
Oh,
right.
I multiplication. Oh, okay.
What is happening?
What was
Why is this not working? Permission denied.
lol.
What are you trying to open?
I'm opening the terminal in my current directory and it says permission denied.
What did you do, bro?
Kernel in your current directory.
Yeah, it says permission denied. Why? Let's just
Just
restart.
restart the VM, bro.
Where was we? Yeah. So we get the whole 2 bytes, and now we're going to uh, unpack. No, yeah, we're going to unpack it using the struct. And for unpacking 2 bytes, we use let's say instruction is equals to struct dot unpack h. I think it's h instruction. So let's just try to first print in hex of this instruction, and let's just not do this while. Oh shit! Let's just do it like this. Oh shit! Uh, let's just do it like.
Are you implementing the disassembler, or the
No, 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 the emulator.
emulator? Okay.
And let's call mu init first and then mu.
What does that struct dot unpack?
I'm going
So
to
that,
explain it. This basically converts these 2 bytes into a
uh-huh.
number.
Number
Uh,
number in the sense.
like this is raw bytes, right? We unpack it to get a, number. I can't explain. Wait, let me show you if my
So
video
it
can.
takes that as bytes and convert to string or like that
No,
something.
it is already a string. When we talk about this is, let's say this is a string of like backslash C0 and then backslash 00. Now you want
It's like
number representation of this. So still permission denied, but we don't care. So let's say we have this. Let's say import struct, and we have our instruction as this backslash C0 backslash 00. Right. This is the exact 2 bytes that we have over here. We can now like struct dot unpack will provide this argument to this. Says that okay, you have to unpack 2 bytes, and then we provide the
Oh,
bytes, and it says it converts these bytes into 192. And now if you see the hex representation of 192, it is it is C0 because the upper byte is 0, so
two
that
bytes
doesn't
are
work.
not transferred.
So for example, if you instead of converting this C0, we convert 41 and 42. Now you will get a number like this, and this number is 4241. It's in the reverse order because of the little endian encoding.
Okay.
Now can we move to D?
Yeah.
Nah. What is happening? I don't understand. Let's if that doesn't work, we have Windows terminal. I don't know why it's not working. And it says it's nothing. Why does it says nothing? What? Can someone spot the bug, please?
You're not calling Emulator?
I'm calling Emulator right here.
yes, you are.
Execute it. Put a print statement somewhere and see what's happening.
So length of
Maybe
argument
it's
is
not going inside
definitely
if
not
condition.
2.
Yeah, try to see if it is not going inside if condition or not. Like maybe put something above those.
Bro, do you know there is a verb you are using not equal to 2, but you should be using less than 2.
Oh, why?
No, less than 2. No, fine. It's fine.
It is fine.
Yeah, it is fine. My mistake.
Let's see what we are getting in our grade.
See my message?
Oh, what?
Oh, you said
What?
ah shit.
What, now it works?
It's no.
Okay, yeah. Well, we
Okay.
can insert breakpoint at least.
What was the ROM file, right? And it says code not defined because where is code?
I told you in that message.
Arjun is saying in range of emu code, not in range of code.
Where?
Where? For slash.
MU. I forgot the MU part.
And you don't have to define global for everything as it is global already.
No, it is not. If you define it inside function, it is not global.
It is not defined in a function, it is defined
Yeah,
globally.
still, it will be
Now as you can
inside that
see,
function only.
we get the
Oh,
You will
really?
get a local variable.
yeah we wait if we have to
Yeah,
increment the program counter
increment.
by 2 because we just So now it prints opcode of all the instructions that we have.
Okay.
Sol0 y sol0 requires, okay, in the end of we reach the end of the file. um, do we have less?
Ooh, I don't think we have this on this.
We have less. It's
Wow,
fine.
Windows has.
Yeah, so this is as you can see, this is the exact bytes from here: C0, then 90, then C0, A0, as you can see. So now that we have these numbers, it's way much easier for us to uh, decode them, uh, right?
Mhm.
Because the problem with earlier approach was that one of the nibble lies in this byte and other two nibbles lies in this byte, so that makes it hard. You have to fetch one nibble from other byte and then get it.
Okay.
So now because what
You're
is,
making it easier
I
to
did it so
process.
far.
huh?
I did until this. I wrote program until this.
Okay, so now where is the PDF? So C, where is the C? Yeah, C says that we get the byte from so let's implement if.
Zero, could you just wait like 10 seconds? I'll just go get my hands washed.
Okay, okay.
What were you doing?
I was eating. I was not doing anything else.
Okay.
All right. Thank you.
So now I'm going to implement. I'm writing the conditions for all the opcodes. So
Okay, what you just wrote is actually equivalent to instruction as equal to 0x0, right?
it just checks that uh, this this uh, s- this nibble, if this nibble is equal to
Mhm.
C or not. If it is, then we do something here. And what we
Wait,
do,
like if you get an instruction and if you do bitwise and on that, isn't it like comparing it with equal to 0, like string compare or something like that?
it will check if this nibble is set, like the bits is set or not. For I can't explain. Wait, I need to use Python. So binary of OXC0, you can see that the topmost two bits are set, and when we do an AND with any number, it checks if these two bits are set or not. If they are set, that means it's our uh, whatever instruction we have. Yeah.
Okay, okay.
And can we do it big and like big endian, because that is going to make our life much easier. If
Why? Why does big Indian make it easier?
Yeah, I'll tell you. Wait.
And also, like if you're doing this bitwise operation, so in case the bits is 1111, like 4 bits, one,
Mm-hmm.
then wouldn't it still pass the instruction?
Yes, it will. We have to do something about that. But first of all, oh wow, we got an error because let's do it A0. Now it is much better. Is it much better? No, it's not much better. Uh, big endian, I think big endian we have this. Now it's much better. Now as you can see, they are exactly similar. C000, C000. Now we can just do this, right? And
Okay.
then argument, let's call it argument is equals to instruction and with OX 0 FF. So now we have argument.
Where do you
Hmm? No,
One less F.
no. All these three x's are argument.
Oh, really?
Yeah.
Yeah, that's in the documentation.
So
Okay.
so this argument is the address, and then we get the byte. Let's oh g-
Oh,
let
okay,
first of all
you're doing.
let me explain you what's happening here, what I'm doing. Uh, let's say we have something. Let's find if yeah let's find look at this C302, right? So
Mm-hmm.
C302 in this instruction, the 302 is the address, and this C represents the opcode. Okay,
Yeah.
and if we AND it with OXFFFF, we will get the only 302 part. So we get the 302 part, which is our address. And if we AND it with OXF0, oh yeah, sorry, my bad. It was we're going to AND it with F00, not C00. Oh no, yeah, C0. We are going to AND it with C00, and if we get back this number, that means it is the like this instruction, whatever this instruction is.
Okay.
Because if we have
So you're
some
trying
other,
to
if
get
we have some
the first.
let's see if we have some other instruction, for example, let's see here, as you can see, there is 1 2 3 4, right?
Uh,
So let's say if we have 1 2 3 4 here, then it will get 0,
okay.
because this 1 is not C.
Yeah.
And for example, we have uh, yeah, but you were talking correct. If we have an F here, then that is a problem. But we have to see if we have an F or not. Do we have an
Think
F?
no.
OP brains.
Oh yeah, we do. We
Oh,
do.
do
We
you
do.
have an F? Okay. So in that case, we're going to do it something like this. We're going to do a hard check. So opcode is equals to instruction and with
You know,
OX.
you're making it easier by using bitwise operator, but we can actually use equal to operator or some other complicated passing
For
tricks
if we
to
use
get that.
equal to operator, then we have to split and do all sorts of crazy stuff,
Ah, yeah, yeah, yeah.
which I don't like. But
Okay.
Oh, this is the difference I told you. Weird programming and good programming.
Yeah, this is good
now one
programming.
more crazy thing
Yeah.
is that here the opcode is like fixed
Zero.
1 byte, complete 1 byte, and here we are only taking the first nibble. We have to
Mm-hmm.
this is going to be a pain in the ass to deal with, because other opcodes are like only one nibbles, 8x, dx, fx, but
Yeah.
these instructions are hard coded. We have to uh, do something about that.
So we should check all that. That's the thing.
If we do check all of them, then we have to ignore this byte for this nibble for the instructions which have like only one. It's let's just implement these one, and then we'll take care of these ones.
All right.
So now here we are going to just do a hard check that if opcode equals oxc, and we're going to shift it right how many times? 12 times.
Wait,
Bro,
go ahead.
opcode equal to, not opcode minus, I guess.
There is no minus, this is equal.
Oh, fuck my phone.
Wait, why are you shifting it right? 12 bits?
To remove these zeros that we get. So if we
To get
do,
the MSB?
yeah, MSN, because we are dealing with nibbles. So if we do it 12 times, we remove these 3 zeros, and we only get the
Go!
C.
Bitwise is such a powerful thing. Security summit.
And so once we have C, we compare if it's C. If it is C, then we will get the address like this. So this is how we get the address. And now we're going to fetch the byte. So byte at address equals to mu code argument, and then we're going to XOR it with OX42, right? And
Zero, zero. One more doubt. Like when you're shifting it to the right 12 bits,
mhm.
all the 12 digits must like go off, right?
Mm-hmm.
And then 0 must be padded in the behind, correct?
Yeah.
But in this, or if 12 of them goes, then wouldn't C also go 0x C?
No, 12
Shouldn't
bits.
that?
12 bits will go. So that this is 12 bits. Three
Ah,
neighbors
oh,
are 12 bits.
yeah,
So
yeah,
these 12
yeah, yeah,
bits go.
yeah,
This is bitwise, not byte-wise.
yeah, yeah, yeah.
Yeah. So and so this is the byte that we fetch and we XOR it, and then we basically store that again
Why
here.
XOR with 42?
That's defined. That's
Documented.
defined. We store that back in argument.
Okay.
Here it is defined here. So where is it?
It's
Here
hard
it
to
says
see.
fabricate xxx and store the result in xxx. Note that
Kodaka, the PDF and the file was actually given in Reverse Engineering channel in our group.
fabricate.
Sorry.
Oh no, you weren't asking. Okay, not you. Never mind.
It says that this is an
Okay.
exclusive OR with
Okay, okay, okay.
OX42. So this is basically, yeah, we are done here. This is the instruction, and similarly we can.
Should we be checking that address if it is writable or not?
Mm-hmm. Yeah, we
You shouldn't
can
give it.
check, but we are not going to bother about it right now. That's your job to do it. Once we get this up and running, that's
Ah,
something we
shit.
can do.
Yeah, sure, sure.
And we have, let's start from this 1 2, and this says that we jump to xxx. So basically, if our opcode is ox2, that means we are going to set mu pc equals to
It's equals to whatever
inst-
argument we are getting.
yeah, instruction
Instruction
and oxfff. Okay.
0FF.
That doesn't matter if you have this 0 or not. This is also
Okay.
fine.
Oh, okay. 12 bits only will come.
Yeah, the lower 12 bits.
All that will come.
So that's fine. Yeah, you implemented the jump instruction. This is the jump instruction. Lol.
Okay.
Lol. And this is one of the compare. It checks if the accumulator is 0 or 1. So if opcode equals 0x3, then we check uh, if what if of one thing we are forgetting. No, are we forgetting? Yes, we are forgetting. This is wrong. We are incrementing the program counter before we execute the instruction. That is wrong. We are going to increment the program counter after we execute the instruction. Right? That makes sense.
Mm-hmm.
So if our mu accumulator is set to 0, then we will we're going to. Okay, now this is.
We can address
There
X6.
is a wonderful bug here. Can you spot it?
Else if?
Yeah.
Else if?
No. It's not about else if.
What is the bug? I don't see the bug.
Wait.
Yep, I don't see it.
One of the bug was this. There was a missing f, but that was not the bug I was talking about. The bug I was talking about is, let's say we have a conditional jump. Okay.
Okay.
Yeah, conditional jumps. You have to
Let's say we
have
have.
a register
Let's say
zero
we.
flag.
No, we don't have it, but we are going to use the
Okay.
accumulator as a 0 flag.
Okay.
So here, let's think about. Let's say we are going to jump at 001. Let's say. Okay, so the jump instruction will be this, right? 2 is the jump instruction. So the instruction will look like, if we want to jump at 001, then the jump instruction would look like this, right?
Yeah, yeah.
So we jumped at 2001 here MUPC is this, and then we'll come here and MUPC will be incremented by 2, and so this will become 3, and we basically skipped one instruction here, the instruction which was at 2001. We skipped it, we never executed it. Did you understand the bug?
Yeah.
And so that to fix that, हेलो किसी के
Yeah.
आवाज आ
Go
रही
ahead.
है?
Who was asking?
So we're going to have an else here to, so if we don't in our conditional jumps, if we don't jump, if we don't jump, yeah, so we have to increment the program counter here by 2.
So we need to like put like incrementation in each and every condition rather than
Yeah,
putting it
I'm
as a
thinking
common
about a
thing.
clever way to like not do that. So let's not do clever.
Maybe set
Let's
a flag.
hmm?
Set a flag.
No,
Set a flag.
no, let's just do it in every instruction. So
If we can set the flag, and then in the next, like we check at the last if the flag is set. If it is set, we
no,
increment.
that's
If it is
going to
not,
make one thing is to like increment it here MUPC plus equals to 2, but
uh-huh.
decrement by 2 wherever needed.
Oh, okay, yeah,
That is
true.
also that is something I've done in my own VM, and
Okay.
here,
So
but
in the starting, you need to add MAPC plus two
yeah, so
in case you.
for example in an unconditional jump we don't want to increment the uh, program counter by 2, so we can just here add MUPC minus equals 2, and so that will be फिटूस हो जाएगा वो जब वो नीचे ऐड
Uh-huh.
होगा तो so here
Okay.
we want to increment because it's a normal instruction. Here we want it to increment by 2. Here we don't want it to be incremented by 2. Here we, if the condition is true, then we jump, and then we don't want. But if the condition fails, then we do want to skip the jump instruction. Otherwise it will keep executing the same instruction. It'll come back and it'll execute
Yeah.
it. It'll come back and
Yeah, yeah.
so we have implemented 4 instructions. And does this look like a hard thing now? It doesn't look like hard
No,
to me, at least.
no, it does. It does.
But
It does.
I'm afraid of lots of code.
You are what?
You wrote 400 lines of code for your bot. You shouldn't be afraid.
So if opcode is 5, we have a jump to address this if A is OXFF. So if MUPC equals OXFF, then we jump. Otherwise, oh no, not MUPC, but MU accumulator. So if that is
Okay.
the case, then we jump to instruction and with OXFF.
FF being 256, right?
Yeah,
Okay.
yeah.
Zero.
Yeah, MUPC plus equals to 2. So that now we have all the jump instructions. Um, this is a very, yeah, this is one of those instructions. But this is only this has only one variant. So compare A to XX and store comparison result in A. What do you mean comparison result? Note comparison results are 0 if okay, 1 if this, and okay, so this is also easier to implement. We basically have to do this. If opcode equals 06, that means this is a compare instruction. Our argument this time will not be OXFFF but FF.
Only two Fs
Yeah,
for the lower two bits,
yeah,
two bytes.
2 nibbles.
Yeah, two nibbles. We cannot call it bytes, can we?
No, you call 2 nibbles 1 byte.
Okay, all right, all right.
Get it?
And one nibble is 4 bits. Yeah, yeah,
Yeah.
yeah.
So our argument here will be instruction and with OXFF, and then we are then
Laptop increment.
if
ഞാൻ ചാർജ് ചെയ്യാനായിട്ട്
mu accumulator equal argument,
Good night.
then we set, so we need to store the comparison result in A. So emulator accumulator equals to
Q is
0.
equals to 0.
If now
You can just put else if.
yeah, here else if elif, right? Elif, yeah.
Yeah, LFL. Why
Accumulator.
don't you just put LF for all the other opcode, stuff? Why do you
Yeah, yeah, yeah. But yeah, that's also cool.
like? Aren't we? I mean, in terms of optimization, aren't we wasting some time by implementing so many years and checking for every? Yeah.
Yeah, you're right. What will we print if else? Else will print segmentation
Wonderful.
fault. Ooh.
Dream of a pawner.
Yeah.
Boys, I'm not a poner. Sorry, I don't understand inside jokes.
So if
It's a
mu
nightmare for you.
accumulator is less than argument, then mu accumulator is equal to 1. Lf mu accumulator is, if it's greater than argument, then mu
Zero, which Python extension is it for Vim you are using?
using you complete me for all. uh,
Oh, that's a nice name for extension.
You complete me. That's what she said.
it's nice, and he has an awesome support for all of the other. Oh, this is a YouTube video.
Unfortunately, me or Arjun cannot say.
I
You
found it. Oh, really? Why?
Look, this is
we
amazing,
cannot.
right? Yeah, that's fine.
I am just adding it.
We are
Why?
Sublime users.
Wh- Why do you guys use Vim and not Sublime?
I don't know. I was watching some Twitch streamer, and he just convinced me to use Vim over other editors. What can
Vim
I
is
say?
awesome, bro.
Okay, can you convince me to use Vim instead of Sublime?
I would just show you that clip of the streamer that convinced me.
Yeah, send me
Vim
the
is
link.
Never switch to Vim because I have seen a lot of people struggling over it.
Yeah, it is. I tried learning Vim, then I gave up. Then I again tried it. Then I gave up. And then I saw this Twitch streamer showing me cool tricks, and then I started like,
Inspired.
okay, I'm going to uninstall Visual Studio Code, and now I'm going to install this. Whatever.
Oh, damn.
It's really OP if you learn Sublime tricks too.
You
Sub,
complete me was last updated 10 years ago.
bruh, what?
Lol.
What?
I
Really?
don't
Okay,
think.
so broke up 10 years ago.
I don't. I don't think so,
Oh, this is a different one,
bro.
I
This is
think.
like 27 days ago.
Okay, the
There are
you complete
some.
me with a single U. I thought that one.
This is you complete me, not you complete. Why do you want to complete someone else? You have to complete yourself, not me. You complete me, not you complete you.
No, he should be completing someone else. We three should be completing ourselves.
Okay, yeah, sure. Let's get back here. So we have implemented the
Yeah.
compare instruction. Now compare A to, oh, now this is a compare with memory location. Okay.
So
L
for that memory location, we can just put array of that emu data
Yeah,
code. Yeah,
mu
emu
code.
code.
Yeah, that's exactly what we can just copy this, and instead of this, we're going to update the arguments value to be uh, mu code uh, at argument, and we have implemented it. So argument is first the oh wait, here an extra f because
And
of the address.
three nibbles.
Then we get the address, and then we get the byte stored there, and then we compare it. And what do we do? Something else. Store the comparison result in A. Okay. Then we have a beef instruction which jumps to OX100 and sets A to 42. Okay. Uh, So do we have any other? Yeah, we have. Let's implement SDF also, and then we'll implement these instructions.
Yeah, sure. We have delete 1337.
Yeah.
That
And
will
we have
change the contents of A.
NOP instruction equivalent with 4E.
Okay. Mm-hmm. Yeah. So let's do this first. Yeah. What? Okay. This is an 8. Okay. Elif opcode equal ox8. What is ox8? Ox8 is set a equal to. Okay. So this is basically a move instruction. So mu accumulator equals to mu code instruction, and
We didn't get the argument.
yeah, this is the
Oh,
argument.
yeah.
And elif opcode equal uh, ux9.
Would you recommend a simpler and understandable Python code over maximizing all the Python code in one or like few lines?
I'll give you the code and you do whatever you want to do with it.
Like as better practice, would you like suggest to make a code
Oh,
neat
okay.
and clean,
Yeah, I would suggest you
or
to
would
make it. Yeah, neat and clean exploits. First thing, always have your exploits very neat and clean. Don't look at my pawn college scripts. And
You
yeah,
lost half of them, okay, bro?
uh, yeah, but if I have to solve them again, I'll be able to solve them now. That doesn't matter then.
You weren't even able to find the vulnerability when I asked you.
It took me 10 more minutes to figure out, but that's okay.
Okay.
I'm still a baby.
So D is XOR this byte with A and store the result in X. Okay, so uh, first of all, argument. First of all, wait, mu code equals to mu code of instruction.
instruction and 0xff is equals to a XORed with code instruction add, right?
Yeah, that's it. And then elif opcode equal.
Have you tried flare-on challenges?
Yeah, I didn't solve them. I was doing Pound College at that time.
Okay, so you are doing pawning. Kodakar, what about you? You do flare-on challenges?
No, I didn't. Next year, I'm thinking about doing them.
Okay, we have
Nice.
implemented all of the. I think we have implemented all of the instructions which have an address of 3 nibbles. Now, uh, I think you guys can implement this, right?
Yeah, sure. We don't need to actually do that opcode stuff to implement 1337, right?
Yes. You just compare this whole
The
this whole
whole
instruction with this,
instruction.
but then you have to like. Okay, now here in else, before we crash, we can check else if instruction is equal
One three
OX1337. If it is, yeah, now you guys
send
can implement it.
serial. What
Print
is
the
serial?
register of A.
Huh?
Oh,
Print the
What
value in the
the hell
register
is
A,
this?
right?
Oh, this is the hex. Okay, yeah. What is this? Okay. Now where do I send this? Okay, let's just. I'm going to implement it. Wait. If instruction is 1337, then we send A to serial out. That means we print A.
and
So
IQ.
I'm going to print. How do we print it? Do we print it as character? Let's print it as a character. Chr of wait for yeah okay chr of mu accumulator and then end equals this. So this doesn't print the end the new line.
Mm-hmm.
And then we have if so this did we implemented beef? We didn't implement
No,
beef.
no.
Else elif instruction equal ox beef, then we will first of all mu pc equals ox 100 and mu accumulator equals ox 42. Then elif instruction equal what else do we have? We have an EEEE to do nothing.
No.
So ox EE we just do a pass and elif. Now we will come to this part. So elif instruction. Okay, now let's do. Wait.
We can do FF00, right?
Yeah, elif instruction. First of all, we're going to AND it with ff00, and then we're going to shift it 8 times.
8 bytes, yeah. Okay.
And then we check
Alright,
if
I'm
this
getting
is
it.
equals to 0x01. If it's 0x01, that means this is add xx to a and store the result in a. So
Zero, like one more dot, like you are shifting it to 8 bytes to
8
right.
bits, 8 bits. That means 2 nibbles. 8
Yeah,
to
8 bytes. Yeah.
yeah,
You will be having like instruction will be having. I mean, whatever output that you're getting will be the first two higher values,
yeah, yeah,
nibbles.
yeah.
If I'm doing it left shift to eight,
Then we'll have something like this.
lower
These
8 bits.
yeah these if we do left shift by 8, then we won't be removing these two zeros, but we will be adding two more zeros. So that means this zeros will remain, and then we'll have two more zeros, which we don't want.
Okay.
So let me show you.
So how do we remove the higher, 2 bytes,
So look,
two
if
nibbles?
we have let's say 1 2 3 4, and if we AND it with oxff00, we get the 1 2, right? And now
Yeah.
we basically shift the whole number by 8 to remove these two zeros. But if we left shift it, then we'll have these zeros plus two more zeros.
0. So how will I remove the higher 2 bits then?
You want to remove these two?
Yeah, using left shift or right shift. Is that possible?
It is possible if only in case of a register overflow. For example, if you have fixed 64 bits, you can just move these 12
Okay.
bits, move this 1 2 out of those 64 bits, and you'll be having zeros. Otherwise, you can just AND it with like one. You have 1 2, and you just AND it with
And
ox00ff. So that means at the place of 1 2, you're ANDing with zeros, and if you AND anything with 0, you'll get 0 at that place. For example,
yeah.
if you have 3 and 4 here, you'll get 3 and 4, and the upper two nibbles are gone.
This, okay.
Okay, so this
Since
first
we are doing 0xff00 with instruction, we are remained with the last two nibbles.
yeah
Thus, we are using that right shift.
yeah we're fetching basically the most significant byte. That is the most significant byte. So if it is
Yeah.
0 0, then our we basically add the argument to the accumulator. So mu accumulator plus equals to instruction and oxff. So basically get the least significant byte, and we add it to the accumulator. Elif instruction and with oxff 0
0xff is also equals to 0x00ff, correct?
Huh? What?
0xFF is also equal to 0x00FF.
Yeah, yeah.
Damn right.
Have you ever used and or in your Python script before, Amanda?
No, man, this is the first time I'm using this. Like, while reading some reversing write-ups, I have actually seen this and odd tricks. And they say for multiplication, you can use right shift and left shift operations, and
Yeah,
division, we can use that and this. So I never actually understood that until now.
And you have to, if you do like if you do something like this, these binary number tricks will be like more often, and you'll like
Yeah,
get a deeper understanding.
rather than
like
parsing it.
compiler optimization.
What?
Yeah,
Yeah, yeah, basically compilers turn multiplication into shifting because that is
yeah,
less what is that is
Overhead.
that is less
it's less
complex.
cycles.
Yeah, yeah, yeah. XOR A with XX and store the result in A. So we, instead of plus equals, we'll have an XOR equals,
It's very good.
and then do we have a multiply as well? No, we have an OR and an AND. So these are basically logic gates, well, logic operations. 0x is 0, 3, right? Yes.
Mm-hmm.
So mu p accumulator or equals to instruction. And oh, one more thing we have to be careful about, that the accumulator is specifically uh, 8 uh, bits, and we may overflow our register while doing these add operations, so that will result in a wrong uh, whatever.
Result,
Yeah.
expected
So
result.
when we, for example,
Yeah,
do a chr, we will get an error that chr, the argument is more than 256 or something.
out of range.
Yeah, out of range.
Uh, can we set the number of like something like that into MUQ in Python?
No, we are going to and our accumulator with oxff everywhere to like limit its like the way I'll show you. Okay, so this part is done finally. Okay, now else we will print segmentation.
Segmentation and exit.
Segmentation bolt.
P dot interactive. uh, okay, so now we have to uh, do the and basically. So here we're going to do it like this: mu accumulator and equals to
It's
oxff.
8. Okay. You are restricting it only to 8 bits.
Yeah.
Yeah.
What the fuck?
It's a recording.
So what?
No, I mean, look at the pain for the win, guys.
Sublime
See,
guys are very happy right
you
now.
see the pain.
Not so much pain now, huh?
You again.
So this we don't require
Bro,
anymore.
like, wait, I have a doubt. Like, when if MUIQ is having 12 bits, say we assume that MUIQ is having 12 bits, then if you're adding it with 0xFF,
Then we
so the first 8 bits will remain and everything, all the other higher 4 bits will become 0.
yes.
Okay, beautiful.
Um, we might want to add it here.
We are implementing a class and an object. We can actually say emu.get accumulator, and in that we
Yes.
can implement this.
Yes. Oh, what is this? Look, there is a bug here.
Okay. You're a neat and clean programmer. Damn, I
Yeah.
appreciate that.
Okay, I think we have
The way he
implemented
says,
everything.
I can
Let's see
see
if
a
we
bug
have.
here.
Wait, Arjun is saying something.
Hmm.
Nah, the way he says, I can see a bug here, I'm like, he having the eyes of the god.
Oh, we haven't implemented the block and the unblock.
We can introduce a list and then keep a loop which checks that list. If it is block,
Hmm.
put that address to that list.
But let's try to. Okay, what I'm assuming here is that it will try to corrupt some locked bytes which are like locked and not allowed to write at. But if we haven't implemented something like that, it will corrupt our program. If we have implemented it, it will stop it from corrupting it. That's what I'm guessing. But let's try to run it and see if we get something out of it. Okay, we got an error. Says that bytes does not support item assignment. Why?
Python to
Oh,
OP.
because we have this and we wanted this. But this code is not a Python 3. How do you convert a byte array? Let's see if we have this. I want to convert it to.
We did it give you like the same thing.
What the fuck is this? Huh? Oh, this is nice. List of byte array of.
Why do you want to? You will get it as a byte array. Why do you want to again convert it as a byte array?
I'm not converting it as a byte. Oh, uh, oh yeah, sure, you are right.
Arjun, I also know programming, Arjun. You see.
And it says a byte like object
எனக்கு
is
தெரிய
required in
மாட்டேங்குதுடா என்
list.
ஃபோனில் நான் இங்கே சேஞ்ச் பண்ணோம் ரைட் பேருக்கா அவங்களோட நியோவேம்பில் போனோம் பார்த்தாக்கா அதுக்குள்ளே அவங்க சேஞ்ச் பண்ணிடுவாங்க.
I can agree.
So now here it complains that we have a list, and so now we don't actually require this since we have those two numbers. We can we can do it like this. Mu instruction and no instructions 0 shifted by 8 times, or instruction 1.
Wait, what did you just do?
Oh, we got a segmentation fault. Let me I'm trying wait let me see where we have a segmentation fault. We went from all the way. Oh,
Wait, what did you just do in that instruction thing?
here so I converted mu code from a byte string to a list, right? So
Yes.
when I'm fetching like this, I'll get the higher byte at the
Like
0th place and the lower byte at the first place. So I left shift
Uh-huh.
the first byte by 8 bytes. So now we have OXC0 0 0,
Uh-huh. Uh-huh.
or with the
Yeah.
lower bytes, so it becomes C0, let's say AD.
Ah, damn. My mind is blown.
But we have a segmentation fault, and now I want to know why. Why do we have a segmentation fault? And there is no instruction that tells this CPU to stop, right?
print out
Should
the
I?
opcodes and everything when
So
the segmentation fault is happening.
let's print out here. So segmentation fault \n, our instruction will print our instruction. So instruction is, let's say, and this, and then backslash.
Why do you guys use format strings instead of the format in Python?
I
Python
don't
format.
I don't like that. I
It's
like
kind of nice.
so I'll use instruction here, and I'll use mu pc. Oh shit. Okay, now let's try running it, and we get instruction is this. Oh, we got segmentation fault because this
Yeah,
is
yeah, yeah.
double.
Wait. I forgot to say.
Yeah,
Uh,
go on,
there
go
is
on.
some problem with the second or third instruction. You may need to even if you implement that block and unblock, there is a problem at the third and third offset.
What problem?
Even if you implement it,
What problem?
like if you do it manually, like go like at the 100th offset C000, right? So 000, you're changing the value from 0 to XOR 42, right? And then we have 9000, which blocks it. And then we have C000 again.
Oh,
So
wait,
that's
wait,
not
wait.
allowed.
Where?
100th
Yeah.
offset.
So C00, we change this byte here.
XOR 0 to, yeah.
Then we do
And then
90, so
9000.
that means we are blocking it.
Yeah. And then we are again doing C00, which is not allowed.
No, but here
Wait,
this is the
wait.
thing. This makes it like if yes, you're right.
C00 should write to that particular offset that we are specifying.
Yeah,
But here it's already blocked. So that
yeah. So
means it shouldn't work.
we have to implement it.
Nice.
Even if you're implementing it, wouldn't you need to raise an exception. So
Why exception? We can just handle it, right?
you would actually like it will actually break at that particular point. It's like you are writing to a non-executable place and executing it. So it's an exception. How would you pass this off? So shouldn't the binary be obsolete in case it is
It
like
should be, but we can ignore it, and we just want the output to be printed. We want the flag, right? We don't care
okay?
about
So
the.
we are passing it. Just
Okay, let's implement
wait.
this crazy thing. So
I'll
argument.
come back in 2 minutes. All right.
Okay, for argument. कुछ मैं भी आता हूँ एक सेकेंड में.
हाँ bro.
Hello.
हाँ bro.
Yeah. Are you back?
Aman Rapi ne.
Okay.
I am not Aman Ra.
Oh, why am I sitting here?
Thank you for
Lol, CSGO.
I'll show you my.
You play CS:GO?
Yes, I play.
Wow. Yeah, how many hours or something? Like you guys, you players have some sort of
I have
thing.
1,000 hours.
Sorry that I asked.
Well, I have some videos also recorded. Okay, let's
Why
get
don't you
to.
play Valorant?
I also have Valorant. Oh, where did it go? Yeah.
You play Valorant, right? Then hit us up one day. Let's all play. Arjun plays, I play, Finch plays.
Okay. I was about to play it tonight, but I thought this is much important than playing Valorant.
Sorry, man. We lost access.
Okay, we have
Yeah.
argument. Let's fetch the argument, which is going to be instruction and with FFF. Then we are going to block that. So we'll have a. Do we have a? Oh yeah, we can just. Yeah, this is easy. We can just have a global list of addresses that are blocked.
Mm-hmm.
So
And just keep checking them wherever we need to check.
mu block
Wherever there is a right instruction, that is.
block equals to this, and yeah,
You
basically
can define a function.
no, we don't. It's just yeah, it's easy. Yeah, look. Yeah, we got the address and we just add it to mu
Yeah, we add it to the list.
block dot append. Oh, but the thing is, wherever we do a write, we have to check if it's blocked or not. That's the tricky part. So we add,
Yeah, but yeah, dot
yeah.
contains that no, dot contains the argument. Then don't do that.
Hmm.
Something like that.
Okay, so if we are writing for an unwritable memory, so what will we do? We break?
Yeah, we can do that, but that'll stop us from getting the flag. We just want the flag.
Yeah.
We need to pass
No,
it then. We shouldn't execute it.
we can just ignore this,
Okay.
right? Ignore this that we are trying to write at.
But in x86 it breaks, right?
It does break in x86, but yeah, it does break in x86, but we
No,
don't
Zero,
want
like
that.
there are in certain opcodes given in the
Look at
hex
this,
term.
man. This
Some
this
of them.
this part is right here inbuilt, so this will crash like as soon as the program starts. At the third instruction is trying to write at the, so we have to ignore it. Otherwise, we have to remove this instruction or patch it, or we don't want
Oh,
that. We just ignore this. If we try to do a write,
okay.
we just
Ignore in the
ignore.
sense we execute it or
No,
we don't execute
yeah, we don't execute it.
Don't
That means
execute it.
we skip that, right? Basically.
it. Okay. All right.
Uh,
You cannot. How would you do pop? Can
it'll
you
just
supply that? Okay, okay.
it'll just remove from the list. Now
Okay, just see.
here we are reading. We are not writing. Here we are also reading, not writing. Uh, Here we are writing. So we have to check if argument in mu block. If not in mu block, then we basically do this, right?
Yeah.
And
Else?
el-
No
else
else.
else we increment the program counter. We have to increment the program counter anyways.
Okay.
Oh, here we
Why,
are
why
going
do
to
you
read.
think they gave the hex term as soon as the third offset is crashes, right? Why do you think they gave that? Is that a mistake by them? Their
What?
side or?
What?
Like they gave the logic turns out to be not possible, right? Why do you think they gave that?
Wait. Before I answer the question, if our address not in mu logo, I'm going to complete this first and then I have to. So here also. Oh, wow. I'm surprised. And then we do mu pc plus equals to
So Zero, do you know JavaScript?
a little bit.
Ruby?
Uh, I don't know Ruby. I do I've done some JavaScript things.
Alright. Rust and Go? Do you plan to use that and stuff
I
like that?
no, I have no plans on using the enemies of reverse engineers, the sole programming languages that gave the pain to all the reverse engineers. I don't like it.
Talking about that, how would you actually reverse a Rust or Go binary?
It's just a pain in the ass.
Oh, shit. There's
There's
no other way to tackle it?
I've never had fun reversing them. I just had a lot of pain, which I still remember. A lot of pain.
Alright, I'm also going to be in pain.
And here we are just doing a pass, but we forgot to increment the program counter. We actually forgot to increment the program counter everywhere. And here we don't need to increment because we are jumping. And where are we doing right? Are we doing
Instruction
in?
lead instruction.
Haha.
If instruction is equal to 0, it's 1337.
Where?
The first, line number 34, 35.
Here we are not reading anything. Oh yeah, but we have to. Oh, yeah, sure. Good.
We have to increment the
Yeah, yeah,
program
yeah.
control.
Yeah, yeah, yeah.
Anywhere
So
else?
any other place that we are missing? Any other read? No, any other writes that we are missing? Here we have implemented it. Any other writes that we are missing? Here we are writing, but we have implemented the check. Okay, I guess there is nothing else except a global mu block as well. I think now it should work. Oh, see, we got some
What's the flag?
output, but it's definitely wrong. Let me see if my virtual machine is. Oh no, why is it happening? Let me see.
Is that Ubuntu just kernel based?
What?
Like, why doesn't it have a GUI?
I was running it in headless mode. In headless mode, it won't have a GUI.
Okay.
Yeah. Why do you even run it in headless mode?
Because I don't want this window to be popped up everywhere. I don't want this window. I can just SSH into it and then start doing my work.
It's all crazy.
But I have no idea why it's not working today.
You don't use Linux, do you? Zero.
Huh?
In the sense Linux only.
I was doing
You
Linux only. First of all, I had a single boot, like not dual boot. I had one operating system that was Kali Linux, and some NVIDIA driver update broke my whole Kali Linux. Then I switched to Ubuntu as my only
I
operating system. That was working fine. Then I switched to Linux
until
Mint, and then I switched to Linux Mint, and then I switched to Windows back because I wanted to play games. I wanted to have all my reverse engineering tools that are Windows exclusive. So
I see. So Windows is good then.
yeah. Oh, what the hell? You are seeing my password.
I was on my phone, I couldn't see properly.
I just saw N and then password.
Oh no, shit! I have to. Am I logged in? Am I logged in? Yeah, I'm logged
Probably waiting on.
in. Why is it permission denied, bro? How do you debug such problem? Like, if you have,
Reboot.
I personally would go and Google it. Copy paste the error and Google.
yeah, but
And me, the first thing reboot, the second thing run. I always run my system on root.
oh, now it works. What the actual fuck, dude? Like, what the fuck, man? Now it works. Wow. This is the headless mode. I also have a here boot Linux.
Gunacha.
So boot Linux boots the Linux in headless mode. Are we missing something?
I am actually not sure.
Okay, now that we have an emulator, we'll have a debugger so that it will output every like it will output certain.
Did you see no? A known quirk of this microprocessor is that any undefined instruction that has the unique effect of decrementing register. How do you implement that?
What?
Or is that to be implemented?
Wait. A unique quirk of this microprocessor is that any undefined instruction has the unique effect of decrementing register A. Undefined instruction
Process.
decrementing register A. Why? This
We did
doesn't
not
make any.
reach any segmentation fault, right?
Yeah, we didn't reach any segmentation fault. We have implemented all of them.
Hi, can I come tomorrow?
Security.
What is it?
I'm going now.
Wait. I think. Oh, first of all, are you?
Wait, man, wait.
Good night. Good night. Good night. Thank you.
Wait. Ah, shit, we are going.
First of all, are you 100% positive that the flag will be printed and not? It won't be in the memory somewhere.
Absolutely not. I mean, Deuterium gave this challenge and he just said, make an emulator for this. You'll get the flag once you complete.
See, I didn't got the flag. Where is 0? You have to make an emulator to run the ROM. After running the ROM, you will get the flag. And Deuterium is in our server, right? He's in our team, right? This guy.
Yes, he's the crypto god.
And now I'm again trying to figure out what the fuck is wrong with this.
Wait, is he even online?
Now it works.
Let me check.
Yay! Now I have the. Okay. Let's now run it in here. We only get an I and a J in Linux, but
I'm not sure which CPU this is also, by the way. So,
we actually get a lot of ones.
uh-huh.
Okay, let's
Okay,
implement.
Deuterium is online. Deuterium is online.
Okay, ask him to join our meeting.
Join the.
So now at every instruction, we can just print the state of the memory, basically. So the way I want it to be is print accumulator and then print And then for each instruction, I'm going to print its description. So for example, hex C is what? Hex C
Hashtag
was
debug.
hex C was what? It was
Mm, XOR with 0x42.
yes,
Get the value from a particular argument and XOR with 0x42.
yes. So how would you how do you want your this emulator's assembly to look like?
I'm actually alright with even a single statement.
Okay. So I'm going to do it like this. Code at ox percentage x dot 4. Let's do dot 3. XOR equals ox42. That's fine. And we're going to have an instruction, or basically argument. So it's going to print it. Oh, look at this. We missed one. Or yeah, we missed. Oh no, this is the jump instruction.
No, we didn't miss. We don't need to increment here, right?
Yeah. So jump percentage x okay. One more thing. Percentage mupc. We also want to know the offset where we are jumping. So how would you do that? Yeah, how
We
would
need to
you
put
do
a
that?
print statement as well, that's right?
No, we can't do that. Let's just not do that. We don't want a disassembler. And here it's what? Compare? No, it is a move. It is a conditional jump. So jump if accumulator is 0, so jump 0 ox percentage x percentage mu pc, and then we have a jump not 0 or jump 1 or something.
Equal to 1.
What the fuck?
Geniuses. Zh3r0 is online and I have asked him to join and it seems he went offline.
So what is this? It is okay. I'm going to do it like this. Jump if accumulator equal 255. Jump if mu accumulator equal 1. Now what is this? This is a compare instruction. So
And returns the value. Yeah.
compare accumulator with an immediate value.
Argument.
Let's just do it like this. Oh yeah, I forgot one thing, which is to pause at every instruction. How would you pause it? So let's just do this.
Input.
Yeah, input.
You really like neat code.
Why are we printing in the next jump? Okay, Accumulator is 0, program counter is 100, and now code is equals to 0x00, and then XOR with 42.
42.
Oh,
That's the
accumulator
program
is
interface.
still 0, program counter is now 102, and now accumulator is still 0, program counter is 104. Then we are doing this, and then this. This is where we again get the hex C instruction, and then we
Mm-hmm.
do this and do this and do this. Okay, so here we printed I because A is 69, which is I, and now accumulator is 13, then it's 3, then it's 6A, so we printed J to 6. Okay, so we are now
Compare.
comparing emul with with F3, and so jump if emulator so it is
Hey,
0,
Retrium joining in.
jump to 126.
Hey, Retrium.
Yo, bro.
But accumulator is not 0. We still jumped to 126. That is a bug here. There is a bug here.
Yeah, so Retrium, like we were having a doubt, Zero was teaching us how to build an emulator. So he taught us pretty neatly and really smooth. But when we execute his code, we're actually not getting the right expected
That
output.
probably is
Yeah,
because
yeah, yeah.
that is probably because my
It's
emulator
like
is not
very
running.
hard to debug. So there might be some bug in an instruction or two.
Yeah. So here, as you can
There
see,
was some conflict also in the program, you know,
What?
like conflicts. Like it says you shouldn't write to a unblocked place, and there was the instruction to write it
Let
after
me
the
let
block.
me let me check the ROM if I gave you the correct ROM.
And we'll get the flag in the ROM itself, right?
Hmm?
when we run the
We'll get the
ROM,
flag.
do we get the flag as soon as we execute the ROM?
Yeah, yeah, yeah. It's working fine, I guess.
Okay.
Okay.
If I think this, if VM accumulator is 0, then we jump. Otherwise, we increment it. Oh, so no. Wait, what the? What? What? This doesn't make sense.
Accumulator is one, and you still jump. Is that it?
So jump to address if A is 0. Oh, so we. Okay, so
ROM.
this doesn't make sense because here, as you can see, our previous instruction was 1 to 4, and since VM accumulator is 1 and not 0, we basically incremented our program counter by 2, and
It's working for me.
we arrived at 1 to 6.
The
But
ROM is working, and
L-
is there a
let
flag
let
format?
let me give. So I modified the ROM. So let me give you the original ROM. So even the modified ROM works, but
Okay.
okay. Nevertheless, uh, I'm putting it on general.
Yeah. You can put it in the reverse engineering channel. You know?
Okay. Wait a minute. Hmm. Reverse.
so this is the output that I'm getting right now. Are you
Wait a
seeing my
minute.
screen?
Okay. What's your output?
What? Oh, just a minute. Like what you gave is the modified ROM before, and what you right now gave is the original one, right?
Yeah, almost similar. So not much of a difference.
Okay.
So the modified ROM also prints something, but just a little bit different, you can
What
say.
I'm going to do
All
is
right.
where is the I'm going to write out the if we have this, then can we do it like bytes and then Latin one maybe, and then we don't have an F yet, but we can do it like this. F is equals to open out right
You're gonna
box.
write it to a file?
Yeah, because I'm also printing this stuff, no? That's why it gets.
Ah, right.
So as soon as we do that, we do an f dot close. So if I execute this, oh what?
Are you doing PC plus equal to 2 in jump instruction?
No.
Okay, okay. And in, I guess, conditional jump?
In conditional jump, if we don't take the jump, then I'm executing. Then I'm incrementing by 2. Where is it?
Okay, okay. That's
Here.
okay.
But
That should be
wait.
fine, I guess.
Yeah. Why is out empty? Why?
You did not write it?
Yeah. Here I'm writing it.
Well, why are you writing it in 1337?
Because that's the instruction of 1337, right? Send A to serial out.
Right.
Hey, maybe you can send it to me and I can check where
No.
possibly you are doing an error.
No, wait a second.
Are we supposed to like increment it twice? I mean, increment it 2 bytes more when we meet with 1337?
Okay, let me check the 13371. Okay, wait a minute.
That should have a plus equals to.
Logically speaking, yes, I think.
No, we are incrementing the. Yes, yes, yes. So you are writing in a file.
Yeah, because I'm outputting some
Debug
debug stuff.
instruction. Yes,
Oh,
debug
okay,
code.
okay. Okay, okay.
But that is also not working even if I'm writing it out on a file. Why is it not working? Oh, because we got
And
an
we don't
error.
treat substitution for.
Encoding without a string argument. Uh,
Okay, okay. Where?
no, I think I made a mistake here. I forgot the
Ah,
Zh3r here.
right.
Oh shit. Okay.
Echo log.
And we got an because we got okay. I guess we have to press like this. Oh wait. What? I think I have to remove this.
Okay, are you loading the ROM correctly
Yes, I'm loading the ROM
at
correctly.
X100?
But the ROM starts. See, the ROM is this, right? So the actual code starts from here, right?
No, 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 no. So you
Zero
load the
hundred.
whole ROM at
Oh,
X100 of RAM.
oh, okay. Okay,
Hmm.
that's easy. I just do it like this. Uh,
Yeah, you can do that.
And we got an error because can only concatenate list. Oh yeah, because this is going.
Your code is bytes.
Yes.
Why can't we just keep it like that? So that means everything else before that 0x100 is
It's
all
also code.
useless garbage.
That's also code, bro.
Alright.
But this is the only thing that I hate. I just have to press. Oh, I'm a dumb
You
fuck.
can just skip that, no?
Yeah. And we got an error that popped index out of range.
Because your RAM is not 4K, I guess. You just made it to be ROM only.
No. This is in the instruction where I'm popping an
Yeah, yeah, yeah,
address.
yeah. So because your RAM should be like 4 KB, right? You are only adding it ROM plus 100.
No, it's not because of that. It's because so it's in here. So this is the instruction that blocks an address, and this is the instruction that unblocks it. So what's happening is here there is an argument passed to this instruction, but this address is actually already unblocked. So I'm going to make a check that if
Zh3r0, I have a doubt.
Okay, sure.
No, never
Sure,
mind.
sure, shoot.
No, never mind.
and we again got this error.
Can you show me your RAM first? I'm just salty about it.
Yeah, wait. But I'm trying to figure out why.
Uh, Zero, why are you doing pop and argument? Pop requires a list index rather than a particular point, right?
No. I wait. If I
Let
do
me
one
check.
three three. Oh wait a minute. So let's say we have a equals to this, and if I do a dot pop,
Four.
No, that would be
Yeah,
the last element.
yeah. But if you are having like three elements and if you
for
give
example,
one of
if let's say a equals to one comma
Yes,
two
yes.
comma three.
Pop takes index. Pop takes index.
Wait. If I want to remove
A
three,
dot pop 3,
yeah, you
it
don't
would be
pop
an
three.
error. Error.
oh,
See?
okay. So that is okay. My bad.
That's a bad design, I would say, but okay.
Why bad
No.
design?
Just remove wherever
We
that
got a
occurred.
segmentation fault. We got 1338.
One three
A
three eight.
moment. Once there is no instruct. Oh, okay. Now I understand. If we
The
have a
note, the
segmentation
note,
fault,
the note, the note. Did you see the note? It
yeah,
said if you have some undefined instruction, then you would need to decrement.
I guess it worked fine. No.
Right, we have a segmentation fault, multiple segmentation fault.
yeah. But these are
Okay,
like better.
okay.
We
Start of the flag is correct. Just load the newer ROM that I gave you
okay. Where is your newer ROM?
in the reverse engineering channel.
I still didn't get why we are, padding it with 100 null characters.
Yeah,
So that's just design based. So usually,
X
like the
max. Is it?
starting
Why does it?
some part of a
Why?
chip is used to just load the ROM, load the
Oh,
code.
okay. Look at this. This is why
So
we got. Look at this. Accumulator got. Oh shit.
Wait, you got my 0 minus 81
Yeah.
so
minus
it should be
86.
it would have been from some 0 to minus 8 even.
Yeah, but I'm doing an and everywhere, but oh
No,
this wait.
and of negative is negative still, you know.
Yes. So how can you do this?
After subtracting, can't you, I mean, and it and then subtract it, maybe? Or subtract and then and it? Something like that.
Wait. Oh yeah.
So Deuterium, like as it says, effectively, all the 100 bytes before that 0x100 offset is actually just garbage value that we shouldn't even consider.
Can be said. Usually in some chip, it would be the code used to load the ROM, right?
Uh,
So first 100 instruction or so would load the later part of the ROM, and then it can modify accordingly. So these chips are like a bit more complicated than your simple x86 program, because x86 program cannot modify its own code. But here is a different case. You know,
It can
so we are
modify.
not. So is in the
x86 can
whole.
modify its own code.
huh?
x86 can modify its own code.
Not anymore, bro. So you have code block and data block in different sections, no? So
Yeah,
you
but
cannot modify the
we can change the
huh?
permissions. We can change the permissions.
So that depends on permissions, no?
Yeah.
But these chips are not designed like that, no?
Uh,
So that's all.
Like the in the whole program, we are only considering the first 100 bytes as null characters, correct?
No, look at that is just padding, bro.
Yeah, yeah. In the whole program,
Yeah.
in this case,
So
at
that
least.
our code is at an offset of 0x100.
Bro, it should be padded. This load file should be padded to uh, 4 KB, right? So you have only just x100 plus the size of this code. That could be one possible bug also, if it is utilizing the whole RAM.
If it was utilizing the whole RAM, I would get an error that is trying to write at an address that doesn't exist. So,
Okay.
so that didn't happen. So I'm assuming that that's not the case.
Hmm.
But what I'm trying to understand is why are we getting what part of code is trying to modify accumulator which doesn't have an and XFF. So we are.
Uh, I think maybe the
I think
implementation
this
of
is this is the part.
unblock and unblock.
This is the part. This is the part. I think this is the part.
Maybe unblock and block is messed up a little bit. Maybe.
The concept of negative numbers in Python. If I do -1, what's going to happen
So
then?
-1, it would be 255.
But still we have this monstrosity.
But minus 260, 256 would return to 0. Okay.
Okay, I think now. What still?
Why do we get segmentation fault each time?
Because of this instruction?
No, for each until from where did it start?
Okay, so it should be, I guess, 1337, and you are somewhere incrementing by 1. So it is getting changed to 1338. It could be something like that. It's trying again and again to execute the
Let's
same
see if this
instruction.
exists in the binary.
No, not necessarily. So it's self-modifying
Oh,
code as far as I remember.
yeah, that's also correct.
Okay, so all these 1338 are supposed to be a character and to be printed out. Hmm.
Wait.
So just jump to the first point where it is getting changed to 1338. We can see what was the last instruction.
As
Damn.
always, Windows.
Okay. Hmm.
We have accumulator as F1. And it's incrementing.
Okay. Can you print the last instruction and what were the states? in your code itself.
The state. Wait. What do you want exactly? The instruction.
At each instruction, print the instruction and the state. I would say.
What state? There is only a program counter and an accumulator.
Program counter and accumulator, obviously.
So it says that I don't think.
We just need the instruction itself.
It's at 17A. Okay, let's just do that. Let's print
What
this.
was the instruction here?
Yeah, that is this is the instruction 17A 017A. This is the instruction. No, wait. The instruction is this.
No, you're only printing accumulator and program.
Oh, okay.
Sorry.
So, so this is the first time we encountered 1338, and before that, this is the program counter, and let's just print the instruction as you are saying. Print Okay, so before we execute 1338, we have an 8300.
So what's that?
8300
shouldn't be an instruction, right?
It should. It is the block instruction, I guess. No, it is.
No, that's 9.
The load accumulator instruction.
So it could be some error far beyond where we are looking.
Look, the 8 one was this. Set A equal to this. Oh, no. Yes.
Oh, you did not check, did you? Oh, no, never mind.
You need to. Okay.
Is the reading? It's
reading.
Yeah, it's a reading. It's not writing.
So we 8300. That means we are fetching from 300 address.
300.
So let's just.
You can.
Wait. So accumulator is 7.
So
and
so what is A300? We also see A300, right?
A300.
Can you check
is this.
A is.
Okay.
A was.
Maybe this is the case. Let's just remove this. A is basically unblock instruction.
Okay. Okay. We again have the same thing.
Why does it stop here? And it also says that if we encounter an undefined instruction, we have to decrement the register. Okay, wait a minute. What if oh yes, that's exactly what I want.
What was the issue?
I want it to be accumulator -1 mod 255 or mod 256. Yes. We got an error. Why? What error is this?
Broken pipe in Python itself.
But now it looks like we have correct accumulator values at least. One more thing I can do is after we do an exit, we can just do a print dot join emu code Whoa,
it would mess up the whole thing. Why don't you write it to a file and we see that?
wait a minute.
Booyah. Completely out of context.
You should probably write it to a file and extend that.
That won't make it. Okay, Deuterium, can you confirm that we do encounter 1338?
Oh, I need to modify my code.
Because if we encounter
Hmm.
1337, it will print a 2f. It will print a
Mhm.
330. That is not correct characters, I guess, because this is 2f. This is a forward
Okay,
slash.
let me just,
Yeah.
if instruction equal to 1338, then I would print something enough. I think it shouldn't be the case itself. Ah, ah.
Why are you doing more? Like, what is the.
Hmm. So
Python.
there is 11338.
Mm-hmm.
I can see only
Oh, array shit, man. Array fucking fuck shit.
PC plus equal to 2. Okay.
Yeah, we got
Ah,
that.
yeah.
Is it
You
the
got
complete
it.
flag? Is it the complete flag though?
Let me check. No.
Yeah. So is it half of the flag or what? How many
Yeah,
characters?
yeah. Half of it.
Why do what the fuck, bro?
So your last character is incorrect. So,
Just
hmm.
one.
So it's not percent, obviously.
Oh no, it's not. Bro, it's
Okay, okay, okay.
that's back. We are missing backslash n.
Mhm.
That's why it's there.
Okay, okay, okay.
So it will close with brackets, right?
No, I think it's not the complete flag.
No, it says Santa uses an emu2. That's it, a phrase.
No, no, I don't think it's a complete phrase. But we didn't, and we encounter any
Why
segmentation?
did you use mod 2560?
Because Python is super crazy. Because Python, if you do like
So integer is a whole class, so it's
yeah,
not fixed size.
yeah.
So
So I do a
that's why
mod
you need
256
to.
to keep it. For example, if in C language, if you have an if you have a character and you have a let's say character equals to 0 and you decrement it, you will get an OXFF. But in
You'll get a?
Python, OXFF, that is 255.
Yeah, yeah.
But in Python, if you do something like that, there is no concept of a fixed size of like 8 bits of number, so it just converts to -1 basically.
So it has its own good and bad, you
Yeah,
can say.
if you do -1 mod 256, then we get FF. So that's why I'm doing a mod.
So when do we get -1? When we subtract what with -1?
We have any variable to be 0. In C language, if you assign a character a equal to 0, That means this character is an 8-bit
Zero.
yeah. That means it's
Okay.
fixed. The size of the zero is 8 bits. So
Mm-hmm.
if we do a -1, it will flip all the zeros. Like
Mm-hmm.
binary of, as you can see, binary of 0 is 0. So if you flip all those numbers, like all those bits, all of the 8 bits, you flip them, you get an OXFF. You flip all the zeros to ones. So,
Uh-huh.
but in Python we don't have a concept of size of a number. So if we do a var equal to 0 and var minus equals to 1, we get -1, which we don't want. We want,
Which is mathematically right.
yeah,
It is
it is
mathematically
mathematically right.
right, but it's
It,
not
Not the correct
everything.
thing
It's in
we
uh,
want.
in
so
other.
we do more
Yeah,
256
we
to
we
get.
want we want this, not this. This is signed. It is signed number. We want an unsigned version of this.
Ah, okay. Unsigned and signed concept.
Bro, Deuterium, tell me how much of the flag do we have? Is this complete flags?
More than half. No, no, not the complete flag. I can tell.
Okay.
How many more characters exactly?
Mm-hmm.
So the last character where it is incorrect should be a decimal point. So it's 2.0. You know. So
Okay.
maybe somewhere in point I can say. I don't know.
Okay, let me do a hex dump on this. Do we have any characters after? No, we have this as the last character.
Maybe you have somewhere to change the operations to the mod 256.
Maybe. But as you can see, a lot of the times we have the accumulator value unchanged. Program counter is actually changing, so that's,
I mean, that shouldn't matter because we got half the flag.
yeah, but maybe we got stuck in an infinite loop somewhere or something like that. What are we actually, how, oh, I know where we are. Oh yeah, I know where we executing. Fucking hell, man.
While true. And we break when we see
Yeah, when we see what,
mu halt.
we don't have
When we
any
see no
option.
code. When we see no code to execute.
And how do you see no code?
Segmentation fault, maybe?
Yeah,
No, no,
segmentation
that won't
fault.
work.
We don't quit at segmentation fault.
Yeah, we don't quit at
This is
segmentation
an
fault.
infinite loop, and then we cat out, and we got the whole thing.
Yeah, you got it.
Nice. Oh, beautiful. Damn, I didn't think emulator was so interesting.
When I first
So this was an easier one. So like everyone solved it, but the other one was like super involving. So that one had like two 220 instructions. So you can imagine the nightmare debugging it. Plus it had a screen, so everything was there printed on a screen. So you had to program the screen also.